Well, hi all, once again, here is John, the founder of John Academy, and today we're going to finish the Algebra 1 August 2025 Regents exam, and we're going to cover the last 4 exercises where you must or you could use the calculator. So the first exercise here is number 12. This one we must use the calculator. Realistically, it's not possible to do it without it, no? Because we need to do the correlation coefficient in a linear model or regression, no? For this table of values. So let's jump into the calculator and see it together. So once here in the TI-84 calculator, we're gonna be going into stat, later there into edit with number 1. And here we're gonna write the 2 columns of numbers we were getting before, no? So the first column was 1, 2, 3, 4, and 5. And then we move with the arrows to the second column here, and we're gonna write 12, 16, and then it's 19, 27, and 29. And now that we have all of these values up here, we are gonna go again into stat, into calc, and we should go into the fourth option, linear regression AX plus B. And yeah, the X list is the L1, the Y list is the L2. We don't need to touch anything here, and we calculate. But this could happen to many of you. You don't see the R value here. This is because we need to turn on something. So we're gonna go into second here, catalog here at the 0, and we are gonna go down up to the D where it says diagnosis on. We are gonna switch this into on. So we enter here. Okay, done. We come back to stat. Everything is as we left it. Very good here. So we go into calc. Yeah, sorry, stat, calc. Fourth option is linear regression. We bring down into calculate. And now, yes, we see the R value. So the R value, there is the R and the R square value. We're going to take the R value, which says 0.9838, no? So we're going to round this to 0.984. And this will be a very strong one. So let's go back to the whiteboard and write it over there. So as we said, we're going to take 0.984 and strong. So it's the first option here. So now for number 27, we have to graph this function, which has an absolute value between the domain of -4 and 4. So we're going to do it with the calculator once again. So once here is very easy to graph that function. We go into the y here, and we need to enter the absolute value. So for that, we're going to do math to the right, absolute value with the 1 here, and then the x is over here, so x minus 2. And once done that, we graph. We're gonna get this function, and we can move around with the arrows, no? We can also go into trace, and we can see this point is 0, 2, no? And the point of the vertex, the lowest point here is around 2, 0. What we can do also is to get a table of values. So for that, we're going to do second and table here, and we get all of these values. So let's take a screenshot of this and use that to graph it in the whiteboard. So now we have over here the table of values. So let's use that to draw the function. No? So when x is 0, y is 2. So that's here. Then we have also, we could use this other one. So when x is 2, y is 0. That's here. And when we could use this other point, when x is 4, y should be 2. So that's symmetric, no? And then we can draw some lines from there, as we saw in the drawing. It's gonna look something like this, no? Well, we just need to draw it between 4 and -4. So 4 is there, -4 would be there also, no? So it's gonna be looking like this, from 4 to -4. We could have done it without calculator also, no? Because this is an absolute value function, and we know it's gonna behave when x is bigger than 2, it's gonna stay as x minus 2, positive, no? And when x is smaller than 2, it's gonna behave as minus x minus 2, which is, if we distribute the minus x plus 2. And this is exactly what's happening, no? This part of the function here is behaving as x minus 2 because x is bigger than 2. And for this other part is behaving as minus x plus 2. That's why. Let's check this next one. Number 31 is a quadratic function. We need to graph also here, no? So let's jump into the calculator and see it over there. So as you can see here, I came back to y equal, no, here on top, and I enter the function, no, the quadratic function. Now we can come into graph, and it's looking like this. We can click again into trace, no? We see that the y-intercept is 4 when x is 0. And we can also move around, no, to try to find the values of the axis. Or even easier, you go into second table, and we have this table of values to draw it better. So let's take a screenshot and check it over there. So now we can use some of these values to draw the curve, no? So we have at 0, it's 4, the y. Then what else? At x equal to 3 is gonna be 1. So that's gonna be over here. And then we saw it was symmetric, no? So we at minus 3 is gonna be 1. And we could give one more value. So let's say at 6 is minus 8. So at x equal to 6, we have to go down to minus 8, which will be over here. And the same way around on the other side, no? It's gonna be here. With this, we have enough values, no? So we could draw it more or less with a pencil. The curve is gonna look, well, sorry, here, something like this. Good. And now they ask us the vertex of this function. The vertex is this point here. So it's gonna be 0, minus 4, no? The one on top. Or 0, 4, sorry. And then the equation of the axis of symmetry. The axis of symmetry is this one. As we can see, no, is symmetric on the x-axis. So that's gonna be x equal to 0. That line is called x equal to 0. Let's do this last exercise. This one, it could be done also with the calculator the same way around, entering both functions or both linear, yeah, in this case are linear functions. But we can do it without it, no? We're gonna see it also here. So first we need to add 2x on both sides, displace that, no? So we're gonna get this into y smaller than 5 plus 2x. And now we can draw both, no? So the first one is minus 3 on the y-axis and a slope of minus 1/2. That means for every 2 we go to the right, we go 1 down. So with that, we can draw the first one already. It's gonna be looking more or less like this. Okay, good. And the other one is y smaller than 5. So 5 is in the y-intercept here, no? Plus 2x. So the slope is for every 1 to the right, we go 2 up. We can draw a line that goes through those 2 points already. So it's gonna be something of this kind, no? Good. And now we have to interpret the inequalities, no? So in the first one, y is greater. So greater than this. So that means all of this here over that one, over that line. And for the second one, y is smaller than the line we drew. Therefore, it's gonna be all of this, the part below. And we see that the area fully colored is this. This is the quadrant, no, or the region out of the 4 that it takes part, no, out of there. So state the coordinates of a point that is in the solution. We could take point 0, 0 here, for example, no? Is inside of that. And how can we check it? Really quick. We can try when x equals to 0 and y equal to 0 and see that both equations should be true, no? So y is 0 greater or equal than, this is gonna become just 0, no? Because it's multiplying x, minus 3. And 0 minus 3 is minus 3, and this is smaller than 0, no? Smaller or greater than 0, therefore it's true. And for this other one, y0, 5 plus 2 times 0, and we see that 5 is bigger, strictly bigger. Therefore, it was true. That point makes part, no, of the system of inequalities. Is there, therefore, no? Very good. So here we saw these 4 exercises, no? This has been all of the Algebra 1 exam, and we will see us in a new exam.